Okay, in this video I wanted to talk about the way that we can use the Cartesian coordinate system to display data sets of ordered pairs, and then how we can use those data sets to find the relationship between data and to see if there even is a relationship between data. So for instance, let's say we take a data set like the one I have here, and we have an x value and a y value. Now the x values would be the independent values. Okay, so these are the ones that are that we may have manipulated in an experiment or something like that, and the y values are the dependent values. So they are the ones that we're actually changing, and that we're watching change and we're observing to change or whatnot. Okay, so what we can do is we can graph these and see how they look relative to each other on the coordinate system, and from that relationship, or from the way that the pattern that they might establish, we can see if there's a relationship, and then we can do some cool things like extrapolation or interpolation sometimes. I'll explain what those concepts are. So the way it starts is that we can first start by looking at different data items, and sometimes we might have data sets like this. So we might have like one data point there, another one here, another one here, another one here, another one here, another one here. And when you have something like this, it doesn't really look like there's any relationship between any of these data items. And so what you would say is that there doesn't seem to be any relationship. Okay, but if we graph these ones, we'll see how they look. So I have ordered pairs here, so I have x is at 1 and y is at 2. So when x is at 1, y is at 2. And what I'll do is I'll just copy this little dot I put in the corner here. Okay, so we have x is at 1, y is at 2. Okay, and then we have when x is at 2, y is at 4. And when we have x is at 3, y is at 6. And when we have x is at 4, y is at 8. Okay, and so then what we do is we get a set of ordered pairs, and we can see that there seems to be some sort of relationship between them, that when x goes up, y goes up, and when x goes up steadily, y also goes up steadily, though at not the same rate. So one thing we would also be able to notice is that we can draw a line between all these points. Okay, now sometimes drawing a line between these points is appropriate, and sometimes it's not. Now, the first thing I guess I should mention is that these values are called variables, and the reason why they are called variables, both x and y, is because they can change, and hence they can vary, and so they are variable values. Okay, meaning that they are uncertain values. Okay, not necessarily uncertain in that we don't know if they're true or not, but in that they can be changed from one thing to another. Okay, so the thing with these variables is that sometimes they are discrete and sometimes they are continuous. So continuous values might be something like someone's weight. So we might track like the volume of their body versus as their weight increases. And so you can have a difference between like 1 and 2, and you can have someone who's like 1.5. Or you could have something like age, so something that's continuous, that like, so for instance, we could graph someone who's, let's say, age versus height, and we could graph someone who's their height as they grow, so from 1 to 2 to 3 to 4 years, and so on and so forth. However, the values in between the dots would still be valid. So for instance, the person at 1.5 would still be a valid one. The person at 1.25, and every dot in between would still be valid, because they would have actually experienced all of the values in between the two dots as well. Those are called continuous values. The difference between, or the opposite of continuous values, are discrete values, and those are values that can only be one thing or another. So for instance, if I wanted to graph something like the pressure on my body as I stacked bricks on my back or something like that. It wouldn't make sense that I could put like, for instance, half of a brick on my back or something like that. In that case, I wouldn't be able to draw a line between these dots, because it wouldn't make sense that I would be loading my back continuously from 0 to whatever. It would just go 1 brick, then 2 bricks, then 3 bricks, and 4 bricks, and so on and so forth. And that would be considered to be a discrete value. Okay. So when we do this, though, what we can do is we can look, and I'm going to assume that these ones are continuous. Okay. And what we would then be able to do is draw a line between them, okay, and show that these are continuous. Now, I'm not going to talk about extrapolation or interpolation in this lesson, but I will talk about it in a future lesson. So what extrapolation is, just to let you know, is us taking this line further in either direction. Okay, so not just upwards, but also we can take it downwards as well. Okay, like that, and say, well, okay, so given these 4 values, what would I expect down here, or what would I expect up here? Just depending on what might happen. Now, it might not make sense, for instance, that, like, for instance, if x were time, it wouldn't make sense to have negative time, in which case we would get rid of this lower half of the graph. Alright, interpolation, on the other hand, is looking between the dots, so saying, okay, well, what happens in between here? And sometimes extrapolation is less reliable than interpolation, because sometimes weird things happen as numbers get big. So like there might be a certain type of relationship when the numbers are small, but the relationship might change or just become completely invalid when the numbers get larger. However, interpolation is often pretty reliable because we can see how the relationship is constant in between a multiple set. Like, for instance, if this case, it's possible that the numbers would actually look like this, right? But it's actually impossible that it would look like that, because you can't have more than one x, so the graph can't double back on itself. But it could look like this, but it just would be highly unlikely that the graph would actually look like that. So in this case, you can usually be sure that interpolation is fairly reliable. However, extrapolation is almost just as reliable as well. Okay. Nonetheless, I just wanted to talk a little bit more about this. So when we have these values, is we talk about two concepts called domain and range. And domain is talking about how much of the x-axis is affected by this here. And I'm just going to just undo some of this stuff here. There we go. So in this case, I'll do the domain in green. The domain, if I were going to draw this, and let's say, for instance, I had the line go like this. Okay. Well, in that case, the domain would start at the origin and pretty much go off into infinity in this direction. Okay, if this were the case. Okay. And so what we would say in this case is that the domain is from, okay, so x is greater than or equal to 0 and less than or equal to infinity. So x goes from 0 to infinity. Okay. The range is another concept, and it talks about how high the graph goes in the vertical direction. So in this case, the graph goes from 0 and it goes up almost to infinity, okay, in the y direction. Okay, and so what we would say here is that the range was that 0 is less than or equal to y, which is less than or equal to infinity. Okay, and so that's how we define domain and range. All right, that's pretty much all I wanted to talk about right now. But suffice to say that using this coordinate system, we can learn a lot about the relationship between data, and to see if it's actually reliable and if there is even a relationship between data items. Lastly, I just want to point out that this sort of relationship, this is called a linear relationship, is not always the same one that you could get. Okay, so for instance, You could get, as I said, you could get one that's just completely unrelated, but you could also get interesting ones like this one, where it starts off where x is changing steadily, but y is increasing in its change. Okay, and this is often known as exponential. Okay, or you can get the reverse, where just going to get rid of this one here. Okay, where looks like this, where it looks like it's falling. Okay, and it's falling more and more. Okay, or you can get all sorts of interesting ones. Okay, so you can get ones like this. Okay, and each one of these tells you something about the relationship. And later on, what we're going to do is we're going to be able to look at some of these and we'll be able to develop equations from these, which will tell us how to predict, for pretty much to extrapolate or interpolate, or to predict what's going to happen at certain points. The shape of the graph will tell you the basic form of the equation, and so it's really important to be able to graph properly and to be able to establish, in order to be able to establish an equation from the data, and then consequently from that to interpolate or extrapolate and draw conclusions from that data set. Anyways, hopefully this has been informative, and if you have any questions, then please drop me a line or send me an email, put a comment in the comment box. If you do like the video, please give it a thumbs up, and if you do like the channel, then please subscribe.